Now here are a few helpful definitions that we want to keep in mind that makes a lot of what we're working with here make a lot more sense. Now suppose, the first one here, suppose we have a curve C that is either in R2 or it's in R3. Now suppose that it's parameterized by, oops, I didn't leave myself enough room. So we're going to say this thing is parameterized by R of t, where a is less than or equal to t, which is less than or equal to b. Now C is then called a simple curve if R prime of t 1 not equal to R, I said R prime, the vector R, t2 for all t1 not equal to t2 in a to b. So what it's saying is pick any two times, t1 and t2, that's in a to b. If the position vectors r of t1 is not equal to r of t2, for all t1 and t2, then we have a simple curve. In other words, what this is saying is that the curve does not cross itself. So something like this would be a simple curve. Something like this obviously is not simple. Okay, the curve C is said to be closed if R of A equals R of B. And that is simply another way of saying that the beginning and starting points are the same. Now, this curve is simple, but it is not closed. This is also not simple, and it's not closed. Something like this, perhaps a figure 8. And actually, I should put orientation into all of these. This is closed, but it's not simple. And then something like this. This is both simple and it's closed. An open region in R2 or R3 is said to be connected if it's possible to connect any 2 points in the region by a continuous curve that lies totally within the region. And we draw some pictures of this in just a second here. Let's go on to this last definition here. An open region, again, in either R2 or R3 is said to be simply connected if every closed simple curve in the region can be contracted to a single point in the region. In other words, the region does not have any holes. So let's just say that here's an open region. I'm going to call it R. Now this is connected because I can take any 2 points in here and I can connect them with a single curve, single continuous curve that's totally within this region. And not only is it connected, but it's also simply connected. Because if I take any closed curve in here and a closed simple curve, I can collapse that down to a single point. There's no holes here. Whereas something that looks like this, here's my region, and say I have a hole right there. So this is the region that I'm talking about. This is connected. pick any 2 points in here, it doesn't matter where you pick them, I can always get there by a single continuous curve that still lies within this entire region. But it's not simply connected. Because if this is a simple closed curve, which it is, I can't contract this down to a single point because there's holes here. Now this one I could, but this one I can't. So because of that, this is not simply connected. It is connected, but not simply connected.